Okay, so they want to know which equation represents this graph, and the way they say it is which equation is represented by the graph below. So which one of these actually would help you plot this graph right here? Now, I'll talk in a moment about how I'd solve this, but I think one easy way to approach it is to say, okay, we've got this line, and this line is made up of points. So let me pick out a simple point, and then plug that into our formulas, and see which one of these formulas, if I plug in the input, or the x value of the point, which one of these formulas gives me the y value, or the output of that point. So here, if we look at this point right here, right, what is this point? It is 0, -3, right? And what that means is that on this line you have a value where x, or the input, is 0. And when you plug that input into an equation, right, you should get -3 because that's the output on the line. So let's plug in an input of 0 and see which of these equations give us -3. And those are possible candidates, right? So first of all, I notice that in equation 1, if I plug in 0, what do I get? Well, x is 0, and that would mean that this is 0 minus 3, so that's -3. This is a possible candidate. 2 does not work because 0 minus 3 is -3 squared is 9, right? We need to get -3. 3 could work because 0 minus 3 is -3. So far, so good. And choice 4, if you have 0 minus 3, right, that's -3, but we're taking the absolute value of that, that would give you +3. We don't want +3, we need to have -3. This point represents an input-output for this function. So there's only 2 choices left. So now what I would do is try and pick a different point to see what's going to happen. I'm going to pick a negative point. For me, negative points tend to cause more issues. In other words, if there's a point where these equations work, which they do here, then hopefully starting with a negative input will reveal when they don't work. So let's try this. Here, this point is -3, 0. Okay, so if we plug in -3 here, right, we should get 0, but we don't because -3 squared is 9, minus 3 gives you 6. That can't be it. And in fact, here, the answer is 3. You can try this point. The absolute value of -3 is 3. Minus 3 is 0. So that one works, right? If you plug in the absolute value of -3 minus 3, that's just 3 minus 3, or 0. And I guess what you can say here is, hey, look, this is the absolute value function, -3. So the absolute value function always will look like this V shape or an upside down version. And you can imagine for a moment some different scenarios. If the absolute value function, as it is when it's just y equals the absolute value of x, when it's like that, what you'll see is this turning point at 0 and then the v going up in equal opposite directions. But if you add some value, add a positive value a, let's say a is something that's greater than or equal to 0, what's going to happen is your graph, if a is above 0, it's going to move up, right? So you can recognize the absolute value shape, and if it's higher, then if the intersection point is above the origin there, then it is something, absolute value of something plus a number. If it's below it, when a is, let's say you have a is less than or equal, say less than 0, it's going to move down, right? Which is exactly what happened here. If you think about the equation, it's y equals the absolute value of x, and then take 3 away. So this point right here is what I would look at if it's down 3 below the origin. It's just the absolute value of x minus 3. All right, hope this helped.